Welcome to our Tools of Coolant video. We'll take a look at the tools most commonly used by shops to check and maintain their coolant. We'll start off with the refractometer. This is the most important tool you'll use for keeping your coolant working correctly. Its purpose is to measure the concentration of your coolant. They are handy when filling an empty tank with a new batch to verify the concentration. But a refractometer is an absolute necessity when topping up a tank with coolant already in it. Without a refractometer, there's no way to know whether your coolant is running rich or lean. If it's rich and you add more concentrate, you will simultaneously reduce cooling capacity and throw money away. If it's lean and you don't add enough concentrate, then you risk short tool life, bad surface finishes, and rusting your machine and parts. Guessing how much concentrate you should add will lead to problems. Don't eyeball it. And measuring your coolant's concentration is easy with a refractometer. We're using a manual model here, but digital versions are also available. Think about this. For less money than this 5-gallon pail of concentrate, you can purchase this tool and never have to guess about your concentration again. So, how do you use one? The first step is always to zero the refractometer, or, in other words, set a baseline for the water you'll be using to make your coolant. Place several drops of the water you're using on the viewing prism and close the plate. Adjust the screw beside the prism until the concentration reading is lined up with the zero line. Wipe off the prism. The baseline for this water has been set. Now, let's check the concentration of the coolant. Take a sample and place several drops on the prism. Let's see exactly where our concentration lies. In this case, it's 8%, right in the middle of the 6 to 10% range, which is acceptable for most coolants. The reading the refractometer displays is a Brix percentage value. This value isn't always the same as the coolant's actual concentration. Here, we're preparing 2 test batches of coolant, one using a soluble oil and the other a full synthetic. Both vials are holding the same amount of concentrate. And both of these pans are holding the same amount of water. We add the concentrate and mix thoroughly. Now, let's see what our refractometer readings come out to. This soluble oil coolant shows a reading of 8% Brix. When you look at the manufacturer's chart for this coolant, 8% Brix equals 8% actual concentration, or 1:1. The full synthetic coolant, however, shows a reading of 3.5% Brix. Looking at the chart for this coolant, 3.5% Brix equals 8% actual concentration. The ratio of this coolant is about 1 to 2.3. The ratios are different, but the coolant concentrations are the same. Be sure to know the ratio of your coolant. Using a refractometer allows you to adjust your coolant based on sound information, not just guessing. What other ways can you check the condition of your coolant? Water quality test strips can be used to check the pH balance and water hardness of your coolant. A pH balance in the range of 8 to 10 is acceptable. pH readings below 7 generally indicate the coolant concentration is weak and increase the chance of corrosion and bacterial contamination. A water hardness reading between 150 and 400 parts per million is acceptable for most coolants. Readings above this range also increase the chance of corrosion and bacterial contamination, and separation of the water and concentrate becomes more likely as water hardness becomes excessive. So, how does the coolant get to this high hardness level? Over time, the water in the coolant evaporates away. But if tap water is used, the hard minerals in the water do not evaporate. Each time you top up the tank with tap water, a new batch of minerals is added to the mixture. After a few rounds of this evaporate and top-up cycle, well, you've got a tank packed with minerals and your coolant may be ruined. This is why we recommend using deionized water instead of tap water. Okay, so we've covered why hard water is a problem and how to avoid it. However, there is one exception we really need to mention. It's actually best to use tap water when you're making a new batch of coolant. The minerals in the water provide surfaces for the oils and additives to adhere to initially, yielding the best possible mixture. Now, a moment ago, we mentioned deionized water. You might be thinking, where do I get this stuff? You can buy DI water from industrial water supply companies, or do what a lot of shops do, and generate it yourself using a water purification system. Large shops with many machines often have complex installations maintained by water purifying companies. For smaller shops, simple, inexpensive units for a few $100s are usually just fine. These simple systems combine reverse osmosis and deionization and can provide more than 100 gallons of purified water a day for a cost of 5 cents or less per gallon. If you attend to the maintenance of your coolant tank and keep your coolant's mixture and chemistry in check, you should never have to worry about bacterial infestations. However, in the unfortunate event that you've let your tank maintenance falter, you may find it turning into a stinky, disgusting mess. At this point, you may need to test for bacteria in your tank. Here, we're using a bug check bacteria test kit. Take a sample of the coolant and allow it to sit over the weekend. On Monday morning, if it looks like this, you definitely have a bacterial infection. In this case, you really have two options. You can add a biocide to your tank, or empty it out and start over. Since biocides are hazardous chemicals, usually the better option is to drain the coolant and clean the tank and pumps. Then, you should prepare a high alkaline cleaner and pump it through the system to kill the bacteria that remains throughout the coolant plumbing. These high alkaline cleaners are usually available from your coolant supplier. They are typically mixed with water at a low concentration and run through the system for a few hours. Run all the coolant pumps on the machine and be sure to empty all areas of your coolant system where contaminated coolant may accumulate, like the washdown hose, for instance. When you're finished with the cleaner, drain it and follow it up with a rinse using a partial batch of 2% coolant in order to completely remove the cleaning solution. Now you're ready to start a new batch of coolant. If you properly maintain your coolant, all this headache should never be necessary. When you need to drain the coolant in your tank, there are a number of ways to do this. The most readily available method, of course, is to use a bucket to bail the old solution out. This starts off easy, but it's difficult to get all the coolant out once the level is down below about 30% full. Some wet and dry vacs can be used to pump water out of a coolant tank. Also, a wide variety of sump pumps exist. Even inexpensive smaller units can often be used to drain the tank of your Haas machine. But it's usually difficult to remove all the chip particles and sludge from the coolant before it's pumped out. So make sure the pump you're using either has a filter screen at the inlet or that the pump is rated to handle sharp metal fragments. Manual pumps can also be used. They are slower and take some effort, but do a good job of emptying everything in the tank. You'll probably need a screen or filter for these manual pumps too, since they will get clogged by chips. When chips accumulate in your coolant tank, a perforated metal scoop can be used to lift them out easily, while letting the coolant drain off. You may recognize the metal scoop we have here. This sturdy cat litter scoop works surprisingly well, and they are easy to find online. Sometimes, really fine chips or sediment-like contamination can reach your tank. Let's take a closer look at how the coolant inlet panel works and when you need to consider using a chip strainer. The perforations on the coolant inlet panel are very small and do an excellent job of retaining even fine chips. In the center image, You can see that even with this pile of fines sitting directly over the inlet area, with coolant passing over them, only a small fraction of the chips make it into the pan. Despite this, over the span of many weeks, if the chips on your machine are extremely small, or you are machining something like cast iron where the chips form a grit-like substance, then a larger quantity of chips can make it into your coolant tank and gradually build up. In this case, you should consider using a chip strainer like the ones that come with your new Haas machine. Stretched over the supplied chip basket and placed above the inlet panel, it allows coolant to pass through while keeping chips from entering the tank. If you're going to mix your coolant manually, a graduated 5-gallon bucket can be used to measure the water and concentrate you'll be mixing. These buckets are readily available for purchase online, or you can make your own bucket. A simple tip to make your own is to pour 1 gallon at a time into your bucket. Measure each 1-gallon increment up to 5 gallons, and then mark the bucket at the measured spacing. If you want to mix your coolant in a quicker and more thorough way, consider using a proportional pump or Venturi mixer. Proportional pumps are usually used when higher volumes of coolant need to be made frequently, and when coolant needs to be pumped over longer distances. When lower coolant volumes need to be made, the Venturi mixer is the less expensive option. The mixer uses water pressure to draw a metered amount of concentrate up into the water stream, where it mixes completely with the water as it's dispensed. The mixer can be adjusted to output a range of concentrations, and once you've found the setting you want, note the position of the dial or mark it in case someone else adjusts it. That way, you can always get back to exactly the right setting with a quick adjustment. Place the mixer's suction tube into the concentrate container and then connect the mixer's water inlet hose to the faucet. When selecting a mixer setting, dispense a small amount of coolant and check it out with your refractometer. Once you have the mixer adjusted to your satisfaction, you're ready to mix coolant. Well, that wraps up this Tools of Coolant video. Stick around for more information on how to search for the tools we mention in this video. Thanks for watching.